Welcome to section 14.1. I'm going to ask you to go ahead and pause the video and read the entire first page. When you're done with that, put the video back on and we'll talk about page 2. All right, so we're going to work on page 2 right now. So the first problem we're going to talk about is example A. It says a professor wants to know what percentage of students at Ventura College are left-handed. Name the sampling method that best describes each situation. Choose your answer from the following: census, convenience, systematic, simple random, and stratified. So when we read the first one, it says she uses the student's 900 number and randomly selects from these to form a sample. So this is sort of like putting them all in a hat and grabbing one out. So we call that a simple random sample. Okay, second example. She samples the first 30 students that she encounters in the bookstore. Okay, well that would be a convenience sample. All right. First, she categorized students by their gender and then randomly selects students from these groups. So this is the one that if you look back here, it's this type where we're putting into two groups. Okay, so that is stratified. Okay, so let's write stratified. Okay, she samples every student on campus. Well, that one, we're in the process of that right now. That's called a census. When you try to get every single person, that's a census. All right. She arranges the students alphabetically by their first name and assigns them a number in that order. Then she selects every 100th student. So if you remember from the front page, that's systematic. Like you have a system there that you're employing. Okay, go ahead and pause the video, do your classwork, and then read the next two definitions and then turn the video back on. All right, so you learned that qualitative data is something it's giving a quality. So it could be either a word or some kind of description. It could be a number. Quantitative, though, has to be a number, and the number has to have meaning associated with the number. Okay, so frequency table. We're going to construct these. It says a t-shirt company had orders for 20 shirts with the following sizes. So we can see all the different sizes there. Construct a frequency table and a relative frequency table. So frequency table just means count them up. How many people had smalls, mediums, large, extra large, all that. Relative frequency is going to be talking about a percent. So this here is just a count, and this here is a percent. Okay, so we're going to go ahead and do a table. Let's see, I happen to have a ruler here so I can make it look decent. Okay, so, and do this. Now you can actually make tally marks if you want. I don't know. That can maybe be helpful or not. We're going to write size here. So our shirt size. If we look here, we can see the smallest one is extra small. So let's make a row for that. Then we go small, and then medium, and then large, and then extra large. Okay? So then if you want a tally column, you can. But I think maybe it might be easiest just to go through and count them up. Okay, it's probably a little faster. And then once we have the frequency, we want to go ahead and find the relative frequency. Okay, relative frequency. All right, so frequency. We're going to go through and count all the extra smalls. So what do we see? 1, 2. That's it, just 2. How many smalls are there? 1, 2, 3. That's it. 3 smalls. How many mediums? 1, 2, 3, 4. How many larges? 1, 2, 3, 4, 5, 6, 7. And how many extra larges? That's an extra small, don't count that one. 1, 2, 3, 4. Okay, so now one way to check that we didn't miss anything is if we add up these numbers here. We know we're supposed to have a total of 20 shirts, so let's see when we add these if it works. Well, we get 2 and 3 is 5, plus 4 is 9, and then this is 11, so 9 plus 11, sure enough, it's 20. Okay, so let's go ahead and put a total row. We're going to need it later anyway. Okay, so total 20. So that's a nice check. Okay, relative frequency. Well, we said that we're figuring out a percentage. So how do we figure out percent? The number of things we're talking about divided by the total. So we're going to say 2 over 20 here, and that's going to equal 0.10 if you get out your calculator, or 10%. So 3 out of 20 is going to equal 0.15 or 15%. And 4 out of 20 is going to equal 0.20 or 20%. So remember, to figure the percentage, I'm just moving the decimal point over 2 places. And then 7 out of 40, which is 0.35, which equals 35%. And finally, do you see my boo-boo there? 7 out of 20. I don't know how it ended up 40. Okay, and then 4 out of 20 is equal to 0.20 or 20%. Okay, so now what should these all total? If these are all the possibilities that can happen to you, the whole thing has to be what percent? 100, right? So let's figure it out and see if that works. Here we have 10. 15, that's going to give us 25, that's going to give us 45, and that's going to give us 45, and another 5 would be 50, and then 30 more would be 80, 20, yep, sure enough, 100%. Okay, so we know we did it correctly. All right, so what is the most, they ask us a question here, don't forget that one. What is the most common shirt size? Well, as we look through here, we can look at the frequency and see how many, what's the largest number, which would be large, or we can look at the percentage. It also says that it's the largest percent. So we would say large, since it occurs most frequently. Okay, so at this point, go ahead and do your classwork and then start the next video for page 3.